In this video, we will talk about the limits. Limits allow us to describe how the outputs of a function, usually the y or fx values, behave as the inputs x values approach a particular value. Let C and L be real numbers. The function f has limit L as x approaches C. If given any positive number epsilon, there is a positive number delta such that for all x, limits notation. The previous definition is confusing, but all it really says is that a function has a limit at a particular value if the function doesn't go crazy in the vicinity of that value. In other words, if you only look at the x values near the value you are trying to find a limit for. Can you graph all the nearby y values in a window? If you can, then we can use the equation notation. The limit of f(x) is equals to L as x approaches to C. This means that the function approaches L as x approaches C. One- and two-sided limits. When we say that the function approaches a particular value, it can do so moving from the left or from the right. The right hand, the limit of fx as x approaches to C. The limit of x approaches from the right. In the left hand, the limit of fx as x approaches to C. The limit of f as x approaches from C from the left. A function has a limit as x approaches C if and only if the right hand and left hand limits at C exist and are equal. In other words, the function must be approaching the same value from both sides. There are properties of limits. Number 1, sum rule. The limit of the sum of two functions is the sum of their limits. Number 2, difference rule. The limit of the difference of two functions is the difference of their limits. Number 3, the product rule. The limit of a product of two functions is the product of their limits. Number 4, constant multiple rule. The limit of a constant times a function is the constant times the limit of the function. Number 5, the limit of a quotient of two functions is the quotient of the limits provided the limit and denominator is not 0. Power rule, if r and s are integers, s is not equal to 0, then limits of fx raised to rs is equals to L raised to rs as x approaches to C, provided that L raised to r over s is a real number. The limit of a rational power of a function is that power of the limit of the function, provided the latter is a real number.